Hi there, I'm Michelle Shabara. And in this course we will learn how to use Kubernetes. Specifically, I will teach you Kubernetes using Nimbella, which is a serverless platform, for the purpose of building your own serverless in Kubernetes. This is the first lesson of the course. Why you may want to learn this? First, let's notice that the use of Kubernetes in the industry is growing exponentially. Every DevOps engineer will state his loves for Kubernetes. But Kubernetes has a problem. Kubernetes is extremely complex. If you take a piece of code and you want to put it into Kubernetes, you have to define a deployment pipeline. You generally have to rely on a tool like Jenkins to build images. Then you will take your code and put it in version control environment. Then you will use Docker to build a Docker image. You will store your Docker image in a Docker registry. At this stage you can take the Docker image and deploy in Kubernetes. You will have to use Kubernetes configurations that can be quite complex to build an architecture. Then, you will ask to a cloud provider for a load balancer. Finally, you can see your application up and running. On the other hand, serverless is much simpler. Using serverless, you always start with your code. You then send it to a cloud provider supporting functions as a service, like Amazon Lambda, Google Cloud Functions or Microsoft Azure Functions. That is all. Your application will be immediately available. One wonders, but couldn't you have a serverless for Kubernetes? And then get the best of both worlds, Kubernetes and serverless? Actually, this is already possible. To understand this, let's start with a cloud environment. A cloud environment can always be provisioned, for example from one of the public cloud providers like Amazon, Microsoft or Google. You may have your own private cloud, on-premises. Whatever is your cloud environment, you can, and frequently will, deploy Kubernetes. Once you have a Kubernetes cluster, you can install whatever you want. You can even install a serverless environment, running in Kubernetes, such as Nimbella. Now you can use a serverless for Kubernetes. You can take your code and send it to your cloud, as is. The serverless environment will make it immediately available. Your users will then be able to use it. The number of users may increase. Serverless environment is scalable. Serverless environment will create new executors for your functions. And it will distribute the load of the users among the various executors. We are going to teach you how to build your own serverless. And we will do it using open source software. We will use Apache OpenWhisk, which is also the foundation of Nimbella. What are the advantages of putting a serverless environment in Kubernetes? Before all, you get load balancing. The load is distributed not just over the multiple instances of a single service, but among all the various available services deployed in your serverless. Then, you get automated scaling. As the load increases, new function executors are created, and even new Kubernetes nodes are scaled up, if there are not enough. Another important feature you'll get from the serverless environment is back pressure management. It is the ability to adapt when the load suddenly increases. What if you can't serve requests fast enough, because some executors are not ready? The solution is to use a buffer that will store all your requests until they are ready to be served. Another important aspect is observability. A serverless environment will allow you to inspect what has happened at any time, storing all requests, responses and logs of the various executions. Finally, we will have standard runtimes, without the need of building ad hoc containers every time. In the serverless environment, you use well-known runtimes for your programming languages. You can send your code to them, and they will run it, without requiring to build an image for each service. How it works? Let's explore the underlying magic. Let's start looking under the hood of the Kubernetes environment, where Nimbella has been deployed. Let's meet the various OpenWhisk components. First, there is a web server. OpenWhisk uses Nginx. The web server is the entry point that is exposed as a service by Kubernetes. The web server communicates with the main component of OpenWhisk, the controller. It decides what to do with a request and handles the load balancing. The requests are not immediately served, but routed to Kafka, that will buffer them. It is the key to handle global load balancing, back pressure and asynchronous execution. Requests will be then served by the invokers. Generally, there are more than one. If there is an available invoker, it will take over the requests. Otherwise, another invoker can be used, as the system is globally scalable. It will create new executor to serve requests as the load grows. Results of execution of requests will be placed in a NoSQL database such as CouchDB, and then returned to the controller, to send it back to the user. Let's see now, in detail, how the execution of an action is handled by an invoker. When an invoker sees a request for the first time, it will create a new executor, starting a runtime. It will then initialize it with the function code. Once the executor is ready, it will be used to serve requests. Invokers will reuse as much as possible existing executors. As the load grows, a different invoker can take over some new requests, and then create a different executor to run the functions. The various executors collaborate each other using a shared state. To keep state, we use an in-memory cache like Redis. To keep larger blobs of data, we use cloud-native object storage. Depending on the underlying cloud, we use Amazon S3 or compatible object storage. You can use runtimes for many different programming languages. For example, you can use Python instead of Node.js. Another frequently used language is Go. There are runtimes available for all the more used programming languages. All those languages can collaborate and share the same state, kept in Redis and object storage. We are Nimbella. At Nimbella, we love Kubernetes. We love also open source. We love building cloud-native stuff. But, most important, we love your freedom. Follow us to learn how to build your open source serverless in Kubernetes.